having this large a body of experts and growing number of students actively thinking about radio spectrum issues and engaging with the regulators who make decisions and policies around the spectrum, recruiting industry partners and working with federal agencies on their issues of concern. We've built something that has never been built before.
Welcome to Spectrum Matters, a podcast presented by SpectrumX, the U.S. National Science Foundation's Spectrum Innovation Center.
This being our initial episode of Spectrum Matters, what better topic to discuss than SpectrumX? What is it? How has it come to be? And why should we care about it? Joining us to unwrap that and other information is Nick Laneman, who is the director of SpectrumX, the NSF Spectrum Innovation Center. He's also a longtime professor of electrical engineering and director of the Wireless Institute in the College of Engineering at the University of Notre Dame.
Also joining us today is Anja Fourie of the U.S. National Science Foundation's National Radio Astronomy Observatory, headquartered in Charlottesville, Virginia.
So why does SpectrumX matter? What purpose does it serve us? We recently sat down with Nick and Anja to discuss this and more. Let's give a listen. Well, welcome everyone. Dr. Nick, Dr. Anja, thanks for being here. Really excited to have you.
Thanks very much, Al.
Yeah, thanks, Al. We're excited to be here.
Excellent. So first of all, let's start from the beginning. What is SpectrumX?
So SpectrumX is a national center for wireless and radio spectrum innovation. It was conceived and funded by the U.S. National Science Foundation. And we are building it to be what we call the world's largest academic hub that is addressing issues about utilizing radio spectrum for different applications that benefit society. Centers like this happen all the time in academia. What's really distinctive about this center is that there's this specific emphasis on the radio spectrum.
What is it now? 28 different institutions, all with different research offices, all with different missions, all with different ways of operating.
Each working group has leadership, director and deputy director. And so we definitely try to identify folks who have the energy and the experience to lead such working groups. We knew that there are so many other uses of spectrum. We needed to have experts who know about radar systems, about military communication systems, about satellite systems. There's also an area of spectrum and spectrum use that is all about fixed wireless systems. The economics and policy of spectrum are just as intricate and fascinating as the technical side. So very early on, even before SpectrumX came to be, in our planning grant, we went to some engineers at Northwestern University who had been collaborating and building up expertise in dealing with the economics and technology of spectrum. And the gentleman that I refer to as the godfather of spectrum economics happens to be at Clemson University. And so we recruited him and the folks at Northwestern that have been collaborating with him for several years to make sure that we had that interdisciplinary nature in the center from day one. Some of our students, graduate students and postdocs, have become faculty that are now actively engaging as faculty members in the center.
This must be a difficult undertaking to explain to the general public and bring them into the tent, so to speak, of knowledge about RF.
Correct. And it's, as I say, really the secret behind science communication or just communicating with the public is really starting, meeting them where they are. So when you ask someone to imagine a day without spectrum, that is really what you're asking them to do, is imagine your life without any of these devices or services that you have grown so accustomed to. There would be no such thing as wireless communication. So, your entire digital life as you know it would not exist. We're talking cell phones, we're talking satellite communications, we're talking autonomous systems, mobile networks, GPS. None of that would be possible. And so we often say to folks, well, did you use GPS to get here today? And they will say yes. And we'll say, you're welcome.
I like to use the term the radio spectrum ecosystem. So this is all of the companies, the government agencies that use radio spectrum. And that's a pretty sophisticated ecosystem. Many different industries like the cellular industry, the Wi-Fi industry, the satellite industry, also the defense industry. Academics have done research and engaged in that ecosystem in different ways, but it's actually a bit challenging for academics to get involved in that very complicated space. A typical academic is conditioned and trained to, do their research and write papers and submit them to traditional journals and conferences that are more academic in nature, whereas government regulatory processes are somewhat foreign to us. And so in a lot of ways, this center is meant to create some better opportunities and to lower the barriers for faculty to track current spectrum issues and to develop technology or policy options for consideration by the ecosystem and by the regulators that make decisions about how to use radio spectrum. And we have to manage it carefully. It affects our lives, the decisions we make, the technology we can develop to utilize the spectrum, and the decisions we make for allocating the spectrum have a dramatic impact on our day-to-day lives, whether we realize it or not. In the early days of wireless technology, if you go back to the 1920s, 1930s, early days of AM radio broadcasting, department stores largely were the ones that had radio broadcast transmitters. And they would try to outpower each other to blast out and cause interference to other department stores' radio stations. It was chaos. And so this is what provoked the federal government to create a spectrum regulator. It was called the Federal Radio Commission in the early days. Over time, it evolved and became these two agencies, the NTIA and the FCC, to start setting some rules. The NTIA, the National Telecommunications and Information Administration, they assign government uses of spectrum. So they largely work throughout the government and they support all the different federal agencies that use spectrum. Then there's also the FCC, the Federal Communications Commission, and they regulate and license the non-government uses of spectrum. So each of these agencies have their own annual proceedings and various processes that they use to allocate spectrum. And what I find fascinating about the history of it all is that just as the technology and the markets for using the technology were evolving, the ways of thinking about spectrum as a resource and managing it as such, and the economics of spectrum and the government policies and regulations around spectrum, they all evolved over the course of the last 100 years or so in some really fascinating and intertwined ways. And they continue to do so, by the way.
The National Radio Astronomy Observatory and other, radio astronomy observatories, we've had to work really closely with the likes of SpaceX, who have Starlink, to be able to do spectrum sharing, and we're doing that quite successfully. And so, we say to the public, well, there is GPS on which you rely heavily, and then there is your satellite internet. How do you decide between those two things? Which would you rather be without?
There are these occasions where very serious challenges creep up. And, the way it's structured, if there's competitive lobbying between one part of the ecosystem or one industry and another part of the ecosystem, often there's no arbitrator to actually try to establish some ground truth and provide some innovative technology or policy options for consideration. And so the National Science Foundation actually formed a memorandum of agreement with the two radio spectrum regulators in the US. It's the first time in 20-something years that I was on the faculty where they took that step. The NTIA and the FCC made a commitment for this project to be successful. So we're building a lot of test and measurement equipment. We've taken that equipment into the field. That has enabled us to do experimentation that would be extraordinarily hard for an individual faculty member or research group to try to accomplish.
What kind of research are we talking about? And how it's used, or how to refine the equipment?
So we built some custom test and measurement equipment that allows us to generate 5G-like signals in that band that is most interest. It's the lower 7 gigahertz band is being studied internationally, but it's also a priority one here in the United States. We took it out to the field around the very large array in Socorro, New Mexico, which is a radio telescope. You've probably seen it in various movies and television shows, like most recently Pluribus. It's highlighted in the first episode of Pluribus. So we were out there in the field and we were generating these signals that are more cellular type signals in that 7 gigahertz band, but then using very sensitive radio astronomy equipment to understand and measure those signals and see how interference might occur and what the propagation looks like there.
And that's a collaboration that might not normally happen without an innovation center like yours.
No, we had 25 people in the field, half of that staff, half of that students. It was like a flash mob. We call it our flash mob of spectrum measurements because we had built these test and measurement platforms and deployed them at about a dozen universities. 9 of them traveled to the field and were configured for taking measurements. And so this is a size and scale of measurements that basically wouldn't exist without SpectrumX.
And when we're talking about sharing the spectrum effectively and efficiently, that's going to need innovation. So
there are no careers, correct? I mean, it's not something that's taught at school, right?
No, and it's become one of our, I could say, our biggest markets, if you want to call that, is actually producing materials, for spectrum and spectrum management education. Firstly, from sort of the high school level all the way through to graduate level and early professional level, but also bringing industry closer to students to be able to do internships, etc. So education was a major part of that, and together with that work, broadening participation. So how do we look at the United States and sort of really bring people into the fold who may not have had, awareness or access to radio spectrum education, purely because they may be in West Virginia, and that's just not something that universities in West Virginia focus on, for example. They were just...
You can't aspire to something you don't know about.
Correct, right? You need to know about it. You need to have an awareness, then build the understanding, then you get to the appreciation. And you need the role models. So, that has been another big drive is, who are the people who work in radio spectrum? I mean, who knew that was even a thing? And so those of us who do know that is a thing, sort of really being able to bring interesting people to the public and to students to say, look at this cool dude, look at Paul Ransom at the NTIA. This is somebody who could be an incredible role model, and you could be that person.
SpectrumX started about 5 years ago. Is that right?
Yes. And it was an initial 5-year grant. We're about halfway through year 5.
How do you think you've done so far? What's your report card, if you will?
In academia, having this large a body of experts and growing number of students actively thinking about radio spectrum issues and engaging with the regulators who make decisions and policies around the spectrum, recruiting industry partners and working with federal agencies on their issues of concern. Well, we've built something that has never been built before.
Where do you see it going and progressing? Where would you like to be beyond where you are now, looking to the future?
Yeah, we've been thinking about that a lot over the last year. So, when SpectrumX started, and this was part of the proposal process, we actually went to industry and we said to industry, where best could education and workforce development serve, industry? What is it that you're looking for? What is it that you need? And the call we heard at that stage was, exactly what we've been doing for the last 5 years. And that is, developing these courses, and this material for students and early professionals to get a real understanding of, radio spectrum and radio spectrum management. So, just to facilitate that sort of entry into the workspace without industry often having to sort of train up staff, because it's like a magic unicorn, this person that you're looking for in spectrum management. So, more internships, more summer school opportunities, even going as far as a resume platform, to which our industry members have access to come to a place to say, where do I find the brightest young minds? Really, without industry often having to sort of train up staff. So I think definitely being able to create that interface between the two is probably going to be one of our major focus areas.
There's tremendous opportunity for young folks to get into this field, to enable them to continue that long history of innovation around radio technologies and spectrum innovation here in the United States. Technology like Wi-Fi, that evolved through a regulatory action, opened up an entire part of the industry, which we now call the Wi-Fi industry, that did not exist before 1985. And that was a very significant step at the time. The United States led in that step. And we've had Wi-Fi companies that are leading companies here in the US for many years now. Similarly, there are some interesting spectrum sharing ideas. We have a CBRS network on our campus where we're doing research, and we can explore what spectrum sharing can look like as that ecosystem develops. That's a US-led initiative. There's nothing else like it in the world. What we're doing with satellites, on one hand, these satellite companies are innovating. They're developing these new low Earth orbit satellite systems, and they're launching them and reducing the cost of launch. And so there's a lot of growth from a technology standpoint, like radio astronomy, like environmental sensing, like military systems. We have to correspondingly come up with ways of enabling them to continue to grow by providing more and more spectrum to them. And so there's just tremendous amount of innovation that is required there. That sets the stage for economic development and global competitiveness for the United States.
Well, thank you both for this conversation. I found it extremely fascinating. And there's so many more questions that we'll have answers for, hopefully, in subsequent podcasts. Thanks again for your time. I really appreciate it, and stay well. That was extremely informative. Knowing what SpectrumX does and the great handle it has on radio frequency, how it affects our lives, the different aspects from academia to business to government, all of these portions of the ecosystem are kind of collaborated through SpectrumX, and it's doing a great job and will continue to do so as we move forward. Thanks to Nick and Anja for their help. That was really, really fascinating. Be sure to check us out on our SpectrumX social media, like and subscribe wherever you can. And of course, be on the lookout for our next episode of Spectrum Matters. I'm your host, Al Feinberg, and we look forward to seeing you again on Spectrum Matters.